I am not okay.
Today's question comes from the 2015 BC exam, type 8, because we're doing parametric stuff. This is a yes calculator question, though I don't think our calculator ever needs to be in parametric mode. We can do all of it in function mode. We're given the velocity equation, or the x component and the y component of the velocity vector, and we're given a initial position at time 1. Part A says find the x coordinate at time 2. So this is a case of what I have is equal to where I started plus what I accumulated of my rate function. So this is a setup that's fairly common using the fundamental theorem of calculus. The initial position in the x coordinate at time 1 is 3, and then we are going to integrate the x derivative, which is cosine of t squared, which is not an easy one to do by hand by any stroke of the imagination, so we turn to the calculator and we can press math 9 to evaluate that integral. 1 to 2 cosine of x squared. I'm in function mode, that's why it's an x. That gives you a value, actually double check, we're in radian mode, okay. That gives you a value of negative 0.44, so if we do 3 minus negative 0.44, we get approximately 2.557, or if you go the truncating route, 2.556. This part is worth 3 points. You get 1 point for integrating velocity of x. You get 1 point for including the initial condition, and then you get 1 point for arriving at the answer. On to part B. Part B, find the time between 0 and 1 that the slope of the tangent line is 2. So, we have a case where we're being asked, at what time does dy dx equal 2? That's the question. So, because we're in parametric world, we know dy dx is dy dt over dx dt, and we're wanting to know when is that 2, at what time. That's the question being asked. So it is once you've understood the calculus of the question, it's dropped to not a calculus level question, but just a solving equations question. So can you do this using algebra, trig, etc.? Doing this by hand also is very challenging. I'm a little stumped on how you might go about it by hand, but since it is calculator active, solving equations with the calculator is simply a matter of plugging one equation into y1 and the other side into y2 and finding where they intersect. So in y1, I'm going to plug in dy dt. Divided by dx dt. And then the y2, I'll stick the right hand of the equation, and we're going to look for the time where they intersect, or the point where they intersect. The graph is ugly, but sure, it's ugly, but the thing is, really, if we were being consistent to the problem, we only care about between time 0 and time 1. So by doing that, we can really narrow down the ugliness of the graph. Change your view window, it stretches it until it's something pretty. Here's the graph between time 0 and time 1, and this is where it intersects at 2. Looks to be somewhere just shy of 1. If we press second trace to our intersect command, it's going to intersect first curve, enter, second curve, enter, somewhere around 0.8. And there we go, 0.840.
We should try checking it.
At t is approximately 0.840. This is worth 2 points. 1 if you write the slope in terms of t. So right there, recognizing the slope in terms of t, and then 2 for finding the answer. All right, moving on to part C. Oh, there's words there. We don't need that. Okay, part C. Find the time at which the speed of the particle is 3. So they're asking us, when is speed equal to 3? That's their question. And every solid calculus student should know that speed is x prime of t squared plus y prime of t squared, all under a radical. So this is what we're trying to solve. So when we plug in our knowns, x prime, we'd get cosine squared of t squared plus e to the 0.5 t squared equals 3. And there's the calculus level knowledge, is finding this equation. And then it's back to the world of using your graphing calculator, of plugging this into your y1 and this into your y2 and finding where the curves intersect. They do tell us, actually there's no constraints on the time, so adjusting your view window, you can get to a spot that includes it. At t is approximately 2.196, or if you truncate, 2.195. This is worth 2 points. One of them is if you write the formula for speed in terms of t, and then your second point comes from having the correct answer. Part D, find the total distance traveled. Total distance traveled. In function mode, total distance is the integral of the absolute value of velocity, which is basically the magnitude of the velocity vector. In parametric mode, the magnitude of the velocity vector is that square root thing that we called speed. So if we integrate speed, we are going to get total distance. So in this problem, we are integrating from time 0 to time 1 our speed expression, because our speed expression is the magnitude of the velocity vector. And e to the half t squared is the same as e to the t. This gives us total distance traveled. Again, integrating this by hand would be difficult, even for the most strong mathematicians amongst us. I don't think I could do it. So we turn to our calculator, and our calculator gives us an answer of 595. Or if you're the truncating kind, like Ellie the elephant, 1595. Bad joke. And integrating speed, 1 point.
There isn't an elephant clip in the video.
You need an elephant clip in the video. I might just have an elephant clip. Be sure to comment, like, subscribe, smash that like button, click the bell for notifications.
And the light.
I need to get 10 likes on this one for approval from my class. And ask good questions, conquer the world. Thank you, bye. Yeah? Is that what I'm supposed to say?
Question.